Okay, here we have our second exemplar. This one's a little bit easier, actually. This is, instead of using rational numbers in fractional form, this algebra question uses rational numbers in decimal form. Okay, so we have h divided by 1.6 plus 3 3/10 is equal to 1 8/10. Check your solution. So process-wise, it's real simple. I'm going to get rid of my constant first. I get h over 1.6 is going to be equal to whatever 1.8 take away 3.3 is. Now, depending on how nice your teacher is, if it was me, I'd say you don't need to grab a calculator. You can do that without a calculator. What do I have more of? Positives or negatives? If I think about subtracting 3.3, I'm going to take 3.3, which I have negatives, and I'm going to subtract 1.8. I'm going to borrow. It's going to be a 5. That's going to be a 1. The answer is not 1.5, is it? What is the answer? Negative 1.5, because 1.8 take away 3.3 is negative 1.5. Now, I'm okay if you don't grab a calculator, or if you grab a calculator and do it. 1.8 take away 3.3 equals negative 1.5. But you do have to know that that's negative 1.5, not positive 1.5. Once we have that, we're going to multiply both sides to get rid of the dividing by both sides by 1.6. And h will equal that number multiplied by a positive 1.6. Negative 2.4 is our solution. Now the last part says check your solution. This is important. So on your test, if it says check your solution, here's what I want you to do. I want you to take your equation, so h, or your expression, h over 1.6 plus 3.3. Just take your algebraic expression and substitute negative 2.4 for your h. And now what we have here is just a BEDMAS question. What do I do first, my division or my addition? Division. So I take my 2.4 and divide it by 1.6. That gets me a negative 1.5. And negative 1.5, let's make that negative. Look at that, negate, it says. Negate 1. That's kind of neat. Plus 3.3. What number should that equal when I hit the equal sign? It should equal 1.8, correct? It should equal 1.8, and it does. So therefore, when I take this expression, which is what this side was, and I substitute the h value, and I simplify it using BEDMAS, I must get the other side of my equation, and I do. So then, because I do, I know that my h value is correct.